Hello, welcome to Arya Meet. I am Arya, I'll teach you Meet. So today's our topic is cyanide poisoning. It is a very important topic and very asked topic, high-yield topic even in your examinations. Now talking about this cyanide, first of all, let's talk about what are the sources of cyanide. Actually, there are lots of sources of cyanide like bitter almond or apricot and lots of foods like that. However, nowadays they are not much important because people are well aware about it, and normally you didn't get cyanide poisoning just because of eating it. Okay, one of the very common one you may have heard is apple seeds. Even apple seeds do have cyanide, but the amount of cyanide is so less. You have to eat a lot of it to get a poisoning, and trust me, it's not a very good experience. One apple seed, it's very bitter. How can someone eat so many apple seed in order to get the cyanide poisoning? So yes, they are not much common. The most common is industrial exposure. Okay, industrial exposure is very common. And in cyanide poisoning, what happens? In complex 4, we have heme, especially of the cytochrome A3 heme. Okay, now this cytochrome A3 heme are in Fe2 plus form or Fe3 plus form. And this Fe3 plus form is actually affected by cyanide. I've already mentioned this in electron transport chain as well. You can watch that video. You'll get to understand about a lot of concepts better than what I'm going to explain right now. Okay, now this cyanide, because it goes to the Fe3 plus and binds to it, it doesn't allow the oxidative phosphorylation, and because of that reason our body cannot utilize the oxygen. Most important thing is that as the body cannot utilize the oxygen, the amount of ATP generation would be less. Even though they may direct towards the production of lactic acid, the amount of ATP is quite less in anaerobic glycolysis in comparison to that of the electron transport chain. Therefore, this would cause a lot of problem to the body. So I mentioned that it has affinity to Fe3 plus, and trust me, this is gonna be the most important method of treatment of this condition. See, we have got iron in one more component of our body, that is hemoglobin, which is in the form of Fe2 plus. So what do? We convert this into Fe3 plus, which is considered to be mid hemoglobin. So in order to convert this, we use a component known as nitrite. We can even use something like methyl aminophenol. So this can also convert. So this is also somehow important. What does the cyanide molecule do? They leave the cytochrome A3 and they come to the Fe3 plus of the hemoglobin. Now this is sent to liver. If cyanide is less, even in smoking as well, there is presence of cyanide. Okay, if the cyanide is less, we have got an enzyme known as rhodase. Rhodase can convert it into thiocyanide. However, if the cyanide is a lot, then in that case, we have to give sulfur transferases. Okay, transferases, like we have got thiosulfate, very important one, and we even have got 3-mercaptopyruvate. Okay, 3-mercaptopyruvate can also convert it, and another is thiosulfate. So what do? We convert it. Let's say not we, liver converts it into thiocyanate, and this thiocyanate is removed out from the kidney in your urine, and in this way you can treat your patient from the cyanide poisoning. Now talking about this, what if you converted a lot of methemoglobin? Because you know that methemoglobin does not have a high affinity, or let's say they have got less affinity for the oxygen. So there can be another problem. So in order to treat this, we give methylene blue. Okay, methylene blue. How do you diagnose if your patient has cyanide poisoning? We have got Prussian blue method. We have taurine, fluorescence, high performance, liquid chromatography. What exactly is chromatography? See, you have got a tube and you send out a lot of liquids. And the liquids which are heavier or which stick better in the walls, they travel slowly, and which are lighter, they move faster. And in that way, you can actually separate the two liquids. So this is considered to be high performance liquid chromatography. So you can even use it. And you can even go for mass spectrography. spectrometry, we say, rather than my mass spectrography. Mass spectrometry, actually in mass spectrometry what we do, we take a matrix, and in the matrix we add our components. Okay, whatever we want to detect, we add those components, and then we pass some ionizing radiations, and because of that reason these components are ionized, and on the basis of their mass and charge they travel through a tube which is placed in electric field, and on the basis of how much time they take we can actually detect the components. So that's a very important technique as well. So we can even use mass spectrometry, and we, in this way, we take the value of lactate. If the lactate is more than 10 millimole per liter, then it's very significant. Even more than 6 can be significant, and cyanide is like more than 40 micromole per liter. Okay, so this is our significant component that we can find in the cyanide positioning. So yeah, you can detect, you can diagnose, you can treat, which I have already mentioned. And one of the major way of diagnosing could also be by the breath. Okay, there will have bitter almond breath, so it is also a very important guideline for us for the diagnosis. So yeah, that was all from my side. I hope you enjoyed. If you like it, give a big thumbs up. If you did not, write it down in the comment section what you want me to improve. I'll try my best to consider it. And yeah, stay curious, stay learning. Bye bye.